Hello everyone, I'm Huabin from Cocos. I'm so excited to meet you guys virtually on this HGC event. Today, I'm going to talk about our cross-platform game engine, Cocos Creator, and our solution for hyper-casual games. First of all, let me have a brief introduction of myself and my co-presenter. I'm Technical Director of Cocos Creator, and Zeqiang will also be presenting with me. He's our GFX engineer. He's also the author of WebGPU implementation in Cocos Creator. So the first part of my talk is to reintroduce the Cocos engine to you. I believe it's worth it because we have gone through a long way till today. Cocos was founded in 2008, the very beginning of modern web mobile game industry. It was the first engine which supported iPhone, and in the very early version of Android, Cocos 2DX have supported one-time C++ development to cross both iPhone and Android. Then in 2015, our new generation editor, Cocos Creator, was released. So far, it has become our mainstream engine product. It has popular node component design, data-driven editor, and a complete cross-platform workflow. About 1 year ago, we released the third main version of Cocos Creator. As the version number increased from 2 to 3, the engine have also upgraded from a 2D engine to a full 3D engine, and is mainly focusing on light mobile gaming experience. So instead of talk, I want to show you some example of hyper-casual games developed with Cocos Creator. So there are 2D and 3D games. Air shooting game, strategy game, roguelite game, and parkour game. As you can see, they are all very high quality. The diversity also shows the capacity of the engine. So now let me show you several famous companies using Cocos Creator. First one is Imperial Saga Eclipse, made by Square Enix. It's published on PC Mobile, PC Web, iOS, and Android native. Second one is a web game made by WFS. They have made almost 100 of popular web games during the last few years. In Japan, web game is still a very common and popular way to play games. Third one is Nano Platform by Ubisoft. It was a huge success. They have brought at least 21 of their amazing IPs onto this party game platform, which is designed for hyper-casual audiences. All Nano games are multiplayer party games, support up to 100 players per match, and all players can start the game from a simple link and just several seconds of loading. Plus, Ubisoft haven't limited the experience to their own platform. They have published the game to all kinds of distribution channels like Pocky, a web portal, TikTok, and operators like Orange. This is exactly Cocos Creator's advantage. It helped Nano games to publish to all these platforms and have such a fast loading experience. Last one is a very successful strategy game last year, Top War. Its first launch was actually on WeChat minigame in China. It was still a very simple merge and strategy game in the beginning. Merge gameplay was very efficient to acquire traffic. Then the developer gradually extended their core gameplay to be a complete 4x strategy game. After they polished the game in WeChat, they finally released it worldwide on iOS and Android native. The lightweight merge gameplay attracted many casual players into the game. With a gradual educating process, a lot of them also enjoyed their core strategy gameplay. Along the trip, Cocos Creator is the reason they can publish their game so easily on WeChat and port to native platforms seamlessly. The fast iteration process also proves the efficiency of Cocos Creator's workflow. As you can see in the previous examples, Cocos Creator have great advantages on cross-platform games. especially on web and instant game platforms. A lot of developers, even industry giants, have started to give a try on these new distribution channels. I think the main reason is to maximize audience coverage, just like all hypercasual games try to do. During recent years, many new web game portals have attracted a lot of attention. They are naturally accessible everywhere, and the content can be distributed or more promoted very efficiently. As for telecom operators and the smartphone vendors, they are also integrating game contents or instant game platforms directly into their devices or built-in system. The instant gaming experience have great contribution to their content ecosystem. At last, social giants like Facebook, WeChat, and TikTok all start to provide instant gaming experience to increase the retention and the stickiness of their apps. What's more, the social engagements on these platforms are magnificent for hyper-casual games. These platforms cover the most vast light users or users who never played game, but with the instant play feature, gaming experiences start to invade into everyone's digital life. Therefore, the game industry is truly extended by these platforms. For this kind of audience, I believe hyper-casual games are best fit by definition. As a game engine company, Cocos invests a lot into hyper-casual game development and distribution. We support iOS and Android native, web and all web-like instant gaming platforms. The package size and compatibility are also the advantage of Cocos, which is very preferable when you want to publish your game to markets like India or Southeast Asia. Our lightweight workflow and the fact that we use TypeScript as development language allow developers to faster expand their game content and team size. Not to mention, Cocos is always a free and open source engine, very friendly to small studios and indie teams. At last, we have often been asked how we earn money. Cocos Runtime is a very good example. It's a commercial solution we provide for social apps and smartphone vendors. With Cocos Runtime, they can build their own instant gaming platform into their environment very easily. It supports all WebGL-based engines and game content. So far, it's been integrated into Huawei, Oppo, Vivo's system, and several social apps. Now, we are getting deeper into the technical side of Cocos Creator. It will explain technically how we can support both native and web platforms seamlessly. Cocos Creator provides an efficient web-based workflow. After assembled all graphics and game content in the editor, developers can instantly run the game in Chrome to debug. After the game logic is okay, user can publish to native platforms and have the same game experience without any modification. Now this chart shows how we achieve to support native platforms, web platform, and all instant gaming platforms. Actually, instant gaming platforms provide WebGL environment as we want to benefit from the web game community. Although it needs some adaptation, it's very similar to the web browser environment. As for native platforms, we have our native C++ engine, which use Metal on iOS and Vulkan on Android. Our renderer is implemented in both C++ and TypeScript to provide a unified upper-level API set in TypeScript. At last, engine framework layer provide features like rendering, scene management, game logic with components, etc., etc. This architecture ensures developers to write a unified TypeScript codebase and runs on all of these platforms. Developers can focus on game content, and we provide the ability to deliver the game experience to much more users. Now let's take a deeper look into our multi-backend renderer. From bottom up, for every different backend, we have implemented the same GFX interface based on different graphics APIs. The GFX APIs are similar to Vulkan so that we can release the power of modern graphics APIs. Based on the GFX layer, we implemented built-in forward and deferred render pipeline on all platforms. The main content we are going to expand today is our latest WebGPU support. That is the GFX WebGPU implementation. WebGPU is the next generation web graphics API standard proposed by W3C. It's equivalent to other modern graphics APIs like Vulkan and Metal. We want to share this because it's our big step into the new Web 3D era. We believe it can release much more creativity on the most open and accessible web platform. Before we go into technical details, I want to show you a web rendering demo we built recently. It has stunning real-time rendering results, including techniques like real-time water reflection, deferred lighting, SSL, TAA, MD's FSR, etc., etc. It reaches over 10 million triangles and runs at 60 FPS on desktop browsers, over 30 FPS on mobile browsers. It's really nice, right? So I believe the adaptation of WebGPU and alignment with native modern graphics is a very exciting ability for future game development, especially for hyper-casual games which want to reach much more users with web platform. So I will let Zeqiang to start his part of his presentation. He will introduce how we adapt to WebGPU in detail.
Hi everyone, I'm Zeqiang Li from Cocos. Glad to be here to share how we integrate WebGPU by using Emscripten. First, I'll give a brief introduction on how Cocos works now. When you build a native app, game logic is written in TypeScript, and it will internally call graphics API in C++ native engine. There is a frame graph before any graphics API is invoked. And in frame graph, we gather information of this entire frame, and then it comes to specific backends, OpenGL ES, Vulkan, Metal, or maybe more in the future. There are two ways to integrate WebGPU: writing WebGPU in TypeScript directly, or writing in C++ and then compile into WASM running on web. Actually, I have done both of them, but finally we chose the second one, so that we can share the same frame graph implementation rather than writing it again in TypeScript. Before you start your implementation, there are a few things you need to know. You should have a check on the latest WebGPU header file. All the graphics API you have to use are included. You can choose a browser which you are familiar with, Chrome Canary or Firefox Nightly or Safari, with the WebGPU feature on. To compile C++ code into WASM, Emscripten is needed. And the WebGPU specification on W3C is very detailed. When you have some questions on how to use the WGPU APIs, you can always find the answer here. And the WGPU design doc, I strongly suggest you to go through these docs. They tells you why WGPU is designed this way. Okay, let's start our first part of implementation. Here's a piece of code to copy buffers to textures. We fill these structures it needs, and then send it to WGPU queue write texture. You may have to write lots of code this way. All of these structures and functions or interfaces are defined in the WebGPU header file we mentioned before. And next, after all the low-level API have been encapsulated to the interface which are more easy for user to use, how do you expose the custom C++ structure or class to the TypeScript? Emscripten provides us few ways. Now here I'm using embind. For example, export a structure named drawInfo. You can see the code here. You have to do this recursively to every single structure until there is no custom member structure anymore. In other words, only Emscripten built-in types are allowed to export directly without doing all of this. You can find more details on Emscripten official site. And finally, we have the C++ function ready. Structures and classes are visible to TypeScript. After extract the native object from the WASM file, you can access the constructor like this. Emscripten also provides us wrapped types, which makes it more convenient to communicate between languages. Here's a simple demo running WebGPU on WASM. You can see the lighting is moving around this guy. Here I'm opening the inspect window. You can see the debug output here. The first object, you can see the cursor. The first object is the native object extract from the WSM file generated by Emscripten. It contains all the structures and classes from C++. And this GPU adapter below is WebGPU adapter. We can even see the hardware capabilities inside. Most of the time we can't avoid bugs. Even sometimes you have to double coding time due to bugs. Here I'm gonna show 3 ways how I debugged while integrating WebGPU. Sometimes you can see these warnings emitted by DORM. DORM is a WebGPU implementation on Chrome. This means you have done something that can't get through the validation. It's not the graphics API like DirectX, Vulkan, or Metal. It's validation of DORM itself. So you can pull the DORM project source code and find these warnings to see how these validations are triggered. In this example, I'm writing to a texture which is not assigned the usage of copy destination. So you can fix this by adding it back. And printf is basic skill but very useful. This is the most frequent way I used during this whole work. Before our code gets executed on the GPU, we have to assemble our pipeline state, the pipeline layout, the binding group, and binding group layout. So here, I'm trying to find out which binding group layout entry is missing. If you met rendering issues, you can modify shaders to output the data you want to debug. But frame capture is much more convenient. You can see everything in this frame: pipeline state, load store action, uniform buffer, input assembler, and so on. Here's an application I found on Windows called Pix. It works for WebGPU frame capture. Before launch browser, remember to give it several flags. I list them here. And after the camera icon turns into green, you can see the arrow here. You can press it and get the statistics of this frame. Okay, here's what we get. On the left of this window, you can see we have copy buffers and draw a cube with 36 vertices at the first pass. And the second pass, we have another 2 draw calls. The picture below, the blue background with the cube at the center, is the frame buffer. Precisely is what the frame buffer looks like at this draw call. Okay, here's the extra part. I'm gonna share an interesting problem I've met in this progress. In Cocos engine, only GLSL shader input is supported. And there is a feature in GLSL, combined texture sampler. Usually, we have to bind texture and sampler respectively to the binding slot. But with combined texture sampler, you just bind them to the same slot. But in metal shader language, this feature is not supported. So we compile GLSL into SPIRV binary. During this process, we can separate the texture and sampler. For those which does not support SPIRV, we use the SPIRV cross to turn the binary into the specific language they support. I do the same on WebGPU, but somehow it costs 10 or more seconds when it launched. So I tried to move the shader process to TypeScript. It improves a lot. And at the same time, we have to remove the combined texture sampler by ourselves. Maybe we have done something redundant in the SPIRV in C++. I'm not suggesting you doing this way. I'm just provide an idea to get things done. So let's take a look. First, in the shader, we have replaced the sampler texture by two separate slots. So you can see here, we also have some extra process on the function. After Chrome Canary 94, using this sampler as a parameter is not supported, so we have to remove this too. And what I've done here is using the raw function definition as a function template. Once we met a call of this function, we specialized it with a corresponding sampler. So you can see here, it turns the raw function above into the specialized function below. And during this, you have to deal with the if-define macro carefully. Okay, this is the sharing of WebGPU today. Thanks for you guys listening. Thanks.
So that's it. Thank you everyone for attending our talk today and hope you enjoyed it. If you have any questions, please reach out via these channels. And by the way, it's the Chinese New Year now, so we wish you all a very happy New Year of Tiger. Bye.
So I think it's time for questions and answers now. So guys, please be brave to type any questions into the chat, into the Q&A sessions. So I think guys will answer them all. So Huabin and Zhang are with us. Hello guys again. So the first question is, what is in your mind? What is the future of WebGL technology in after pandemic time? Are some focus from you guys? Predictions maybe.
Okay, I will start. Hello everyone, I'm Huabin. Thank you for listening my speech and for listening to the speech of me and Zheqiang. We think for as a web engine, game engine, we think the future of web technology is definitely arriving now. Just in this year, 2012, we will reaching to a new era of web GPU. So the web content will be much more powerful and have much more potentials. We can try every possibilities on the web directly, and the web is the most open, most accessible platform ever. So it's a really good news for many industries.
Zheqiang, so what about you?
So I was talking some about the technology. we have just implemented, integrated the WebGPU into our engine. So the next step, maybe, I think there's a frame graph, fully frame graph implementation of the low level of WebGPU. So it has a great benefit for our performance, especially on web. So I think it's quite important.
Mm. Okay, great. And the next question is the second. You have talked a lot and showed us a lot of slides with coding. So I think it's really exciting. So the question is it possible some integration with a wider set of programming languages with WebGL or not? Is it planned for other programming languages?
Other programmers. What do you mean by other programmers?
Programmers who know other programming languages. I mean,
Ah,
so will it be possible for them to code on other maybe languages?
Yeah, sure. We have an abstract layer. I mean, we encapsulate all of the backends into a into an interface more easy for user to use. So you don't have to care about is WebGL or WebGPU or WebGL2 or not. You just programming in our interface provided by us. So now you can programming in TypeScript. I think TypeScript is easy for us to programming.
All right. Yes, it was exactly what I wanted to hear about high-level programming interface.
Yeah.
Great. I think Huabin currently absent. So, guys, I think Zichan, thank you a lot one more time. I think it was a really brilliant technology, really brilliant tool, and I hope that it will be useful for a lot of guys listening to us. So, thank you again, and see you later.
Yeah, okay. Thank you. My pleasure.
Okay.